Hi! In this video, we'll learn how to determine the usability of a dataset and why it's important to use one of high quality. There are a few different criteria to consider when determining the quality of the dataset that you'd like to use. We've already learned a bit about this during the data cleaning lesson. The completeness of a dataset is very important and a key principle in figuring out the quality of a dataset. Missing values can detract from a dataset's usability. We've learned that you can take steps to remove or replace missing values, but this leaves room for error or even bias in your data. A quick way to see how much of your data is missing is to use a percentage. We can do this by using a few different functions. The isNull function and the sum function, both together, will help to see the total number of missing values. Here we see that we are missing 75 values in the ratings column and 75 in the voters column. This means there are 150 missing values, which sounds like a lot. However, some of these datasets are huge, so finding the percentage will help adjust what these numbers actually mean. If we use the mean function instead of the sum function, it will give us the decimal fraction of the values that are missing. After that, we can clean it up a bit by rounding. That looks much better. We can also multiply it by 100 to clearly see the percentage. This shows that only 5.77% of values are missing in the rating and voters columns. Even though this is a relatively small percent of the dataset, you'd still want to investigate to see if this missing data is random or representative of a certain subgroup to avoid bad or biased data. Another factor that can affect a dataset's quality is its uniqueness. This metric has to do with duplicate entries. In this book dataset that we've been using, we can see that there are a lot of duplicate records. This can throw off the data a lot. Even our earlier percentage of missing values is now not reliable since there are so many duplicate rows. Luckily, we've learned of a simple function that can drop these duplicate results. As you can see, this dataset contains a lot of duplicate rows. We can drop these duplicates to increase the quality of the dataset. Two other factors that contribute to the quality of a dataset are the validity and accuracy of the data. These two criteria are similar in nature. The validity of a piece of data deals with whether the correct piece of data was recorded. If you ask for someone's zip code and they enter tomato, well, this isn't a valid piece of data. Accuracy, on the other hand, depends on the correctness of the data. If a person doesn't know their zip code and just enters 12345, well, this is valid data, but it's not accurate. The validity of data is much less difficult to find and clean than the accuracy of data. How can you tell that a piece of data was recorded with accuracy? Well, one way you would do this is to consider and compare a few different datasets. And this is where the last criteria comes into play. The consistency of a dataset is important to be able to compare or merge different datasets. There should be consistency in the units of measure used or the way the data is collected. If you are collecting the ages of a group, it would be very difficult to compare across datasets if someone could enter, let's say, integers in one dataset, floats in another, and strings in a third. Lacking consistency would make it really hard to work together between datasets. We can fix issues with the consistency of our data in a few ways. One is with the replace function. Let's say this is our data frame that holds these inconsistent values. We can denote the data frame and the column and use the replace function to make changes. The replace function takes a toReplace parameter, which is the value or values that will change, and then also a value parameter, which is what the values will change to. You can put one value at a time in the toReplace parameter, or you can use a list of multiple values to change. Now, as with any change, you'll want to really consider how changing the data might affect the accuracy of the dataset. You don't want to round or change numbers if it will negatively affect your dataset. Let's say, in this case, the half year is not important, and we want to change the 10.5 and the string of 10 to just an integer of 10. Since we'd like this change to be permanent, we also must add in the inPlace parameter and set it equal to true. When we print out the data frame again, we can see that we have fixed these inconsistencies between the three values. You might be thinking how you could possibly find all of these inconsistencies in a huge data set. There's a Python library called Fuzzy Wuzzy that can help with this. This library compares different strings and scores them based on how similar they are to each other. For instance, If we are trying to find books by Agatha Christie and want to make sure that our data is consistent, Fuzzy Wuzzy can be used to find similar strings. This will help us to find these discrepancies and replace the values. We'll take a closer look at how this library works in the next live code video. Alright, well now it's your turn to dive deeper and explore more about these concepts.